The United Nations Sustainable Development Goals, set up in 2015, clearly points out to the urgent need to adopt responsible patterns of consumption and production, promoting resource and energy efficiency to reduce greenhouse emissions, to hit Paris targets, and avoid runaway climate change. At Cerena, there we develop research on physical, chemical, and biological processes and materials for valorization of mineral raw materials, treatment of gas and liquid effluents, for water and soil remediation, and for recycling solid waste from a wide variety of sources. Let's look deeper into the research on gas and water decontamination, highlighting the excellence of Cerena on this field. Many efforts has been made. Due to the known greenhouse effect and climate change, a social and governmental pressure for the reduction of carbon dioxide emissions has been growing worldwide. A framework of taxes imposed on the carbon dioxide emissions was set up in an attempt to decrease the emissions from the industry. However, a substantial decrease can only be achieved in the next decades if effective methods for the removal of carbon dioxide from industrial gases are implemented, and the carbon dioxide can be used afterwards for other applications. One of the possible methods to capture carbon dioxide from flue gases, biogas, and natural gases is the adsorption onto nanoporous materials, which have pores close to the dimension of the molecules. These materials, also called adsorbents, have significant advancements in the recent years. Nowadays, it is possible to obtain adsorbents with very distinct properties. For the efficient separation of carbon dioxide from the other compounds in the gas mixture, it is of paramount importance to have adsorbents have a strong and selective affinity for carbon dioxide and not for the other compounds in the mixture. Several nanoporous adsorbents were explored at Cerena for these challenging tasks. Some of the studied materials were clay-based adsorbents, periodic mesoporous organosilicas, activated carbons, and mesoporous silicas functionalized with amines. These last ones are currently being considered as one of the best feasible options for carbon dioxide capture and were under the focus of detailed studies. Indeed, the research work was planned to study a set of topical amine functionalized mesoporous silicas with combined advanced adsorption and spectroscopic techniques to clarify several molecular aspects of the carbon dioxide capture by these materials. The findings are of paramount importance not only from the fundamental chemistry standpoint, but also for the development of applications in the upgrading of methane from bio or natural gas sources using purification methods based on the adsorbents.